Here in this section, we have derivatives of trigonometric functions. The derivative of the sine function is a cosine function. So what we have here is derivative of sine x with respect to x, that is equal to cosine x. And the derivative of the cosine function is negative of sine function. So here on this part, we have derivative of cosine x with respect to x, that is equal to negative sine x. Here on this part, we have this graph for y equal to cosine x, and here is y prime equal to negative sine x, which is the derivative of cosine x. So the curve y prime equal to negative sine x as the graph of the slopes of the tangents. So these are tangents to the curve y equal to cosine x. Here on this part, we have the derivatives of the other trigonometric functions. Derivative of tangent x with respect to x is equal to secant square x. Derivative of cotangent x with respect to x, that is equal to negative cosecant square x. Derivative of secant x with respect to x, that is equal to secant x times tangent x, and the derivative of cosecant x with respect to x is equal to negative cosecant x times cotangent x. Example, find derivative of tangent x with respect to x. From previous page, we know what the answer is. This is equal to secant square x. But what if you forgot what the answer was? So here is how we can find the answer for this part. So find the derivative with respect to x. Here tangent is equal to sine x divided by cosine x. And this is equal to derivative of sine x multiplied by cosine x minus derivative of cosine x multiplied by sine x divided by cosine square x. And this is equal to cosine x. Derivative of sine is cosine, so minus sine x times derivative of cosine is negative sine x divided by cosine square x. Now here what we have is cosine times cosine, so that is cosine squared, plus here we have negative, and here on this part we have negative, so negative times negative is positive, and sine times sine, we have sine squared divided by cosine squared. Now what we have in numerator is cosine squared plus sine squared, and that is equal to 1. So it's 1 divided by cosine squared x. And this is equal to secant square x. So this is our final answer. Derivative of tangent with respect to x, that is equal to secant squared x. Find derivative of y with respect to x for y equal to cosecant x divided by 1 plus cosecant x. So derivative of y with respect to x is equal to 1 plus cosecant x times derivative of cosecant x minus cosecant x times derivative of 1 plus cosecant x divided by 1 plus cosecant x squared, and this is equal to 1 plus cosecant x times derivative of cosecant is negative cosecant x times cotangent x minus cosecant x times derivative of 1 plus cosecant x. Here we have derivative of 1 is 0 and derivative of cosecant x is negative cosecant x times cotangent x, and then divide by 1 plus cosecant x squared. And now here multiply, we have 1 times negative cosecant x cotangent x, and here multiply cosecant x times negative cosecant x cotangent x. And same thing on this part, multiply. Here we have negative cosecant x times cotangent x minus cosecant square x times cotangent x plus cosecant square x times cotangent x divided by denominator we have 1 plus cosecant x squared. And here in numerator we have negative cosecant square x cotangent x, and here positive cosecant square x cotangent x. So adding these two, that part is 0, and what's left here numerator is negative cosecant x cotangent x, and denominator we have 1 plus cosecant x squared. So this is our final answer. Now here on this part, find derivative of s with respect to t, and s is equal to t to the 4th power minus secant t plus 3. So here derivative of s with respect to t is equal to derivative of t to the 4th power minus derivative of secant t plus derivative of 3. So derivative of t to the 4th power, moving forward to the left, this has 4 times t cubed minus derivative of secant t as secant t times tangent t, and derivative of 3 is 0. So here is our final answer for this part. Is 4t cubed minus secant t times tangent t. Find derivative of r with respect to theta. R is 5 minus theta to the 4th power times sine theta. The derivative of r with respect to theta is equal to derivative of 5 minus theta to the 4th power times derivative of sine theta plus derivative of theta to the 4th power times sine theta. So derivative of 5 is 0 minus theta to the 4th power, derivative of sine is cosine, plus derivative of theta to the 4th power, that is 4 times theta cubed times sine theta. So our answer is negative times theta to the 4th power times cosine minus 4 times theta cubed times sine theta. So here is our final answer for this part. Find derivative of r with respect to theta. R is 5 sine theta cosine theta. The derivative of 5 sine theta cosine theta with respect to theta is equal to 5 times derivative of sine theta cosine theta with respect to theta. And this is equal to 5 times sine theta derivative of cosine theta plus cosine theta derivative of sine theta. And that is 5 times sine theta derivative of cosine theta is negative sine theta plus cosine theta times derivative of sine is cosine. So here we have sine theta times negative sine theta, so that is negative sine squared. And we have cosine theta times cosine theta, so that is cosine squared. So this is 5 times negative sine squared plus cosine squared, and that is negative 5 sine squared plus 5 cosine squared, which is the same as 5 cosine squared minus 5 sine squared. So this is our final answer for this part. Find a limit of cosine negative 4 pi divided by x minus pi divided by 5 as x approaches 5. Here on this part we have composite function. So here what we have is one function is cosine. So gx is cosine, and f of x is negative 4 pi divided by x minus pi divided by 5. So here we have g of fx So here in this case, we have x in denominator, and for this part, this function is continuous for all real numbers except for 0. But this one, cosine, is continuous for all real numbers. So domain of g of f(x), cosine negative 4 pi divided by x minus pi divided by 5 is all real numbers except for 0. This means that cosine negative 4 pi divided by x minus pi divided by 5 is continuous at 5. Since g composed with f at x is continuous at x equal to 5, so what we have here is limit as x approaches 5, g composed with f at x equal to g composed with f at 5. So here our limit of cosine negative 4 pi divided by x minus pi divided by 5 as x approaches to 5 is equal to limit of g composed with f at x as x approaches 5. And this is equal to g composed with f at 5. So that is equal to cosine negative 4 pi divided by, instead of x, now here we have to use 5 minus pi divided by 5. So that is equal to cosine negative 5 pi divided by 5. And that is cosine negative pi, which is equal to cosine pi, and cosine pi is equal to negative 1. So here's our final answer. Find limit of tangent 9 divided by 4 pi minus pi sine t divided by t as t approaches 0. Tangent is continuous at every point in its domain. However, in this part, when we have t approaches 0, so we're going to have 0 in the denominator. So I'm going to use limit of sine theta divided by theta as theta approaches 0, and that is equal to 1. First, I'm going to find limit of 9 divided by 4 pi minus pi sine t divided by t as t approaches 0. That is equal to 9 divided by 4 times pi minus limit as t approaches 0 of pi times sine t divided by t, and this is equal to 9 divided by 4 times pi minus, here we have pi, and limit of sine t divided by t as t approaches 0, that is equal to 1. And here we have 9 divided by 4 times pi minus pi. So this is equal to 5 divided by and this is equal to 5 pi divided by 4. Now finding tangent of 5 pi divided by 4, that is equal to 1. This means limit of tangent 9 pi divided by 4 minus pi sine t divided by t as t approaches 0 is equal to 1. So this is our final answer.